Alrighty, so in this lecture, I'm going to talk about our next topic for exam 3, which is judgment, decision making, and reasoning. And this topic can be found in chapter 13 of the Goldstein text if you're following along in the textbook. All right, so as I said, our next topic is actually going to include 3 different cognitive processes that are all somewhat related, right? So we have judgment, reasoning, and decision making, right? So I'm going to give one example for you guys that kind of nicely illustrates all 3 of these processes. So I'm sure all of us remember being in elementary school on the playground or maybe in PE class and playing dodgeball with our classmates. And one of the most challenging aspects of dodgeball is inevitably when you are split into teams, right? And you have those team captains who are responsible for choosing which kids they want to be on their team. Right? So let's put ourselves in the position of a kid playing dodgeball who's deciding which of his friends he wants to put on his team, right? Or have on his dodgeball team. So you might imagine the first thing that happens is he sort of looks around at all of the kids and he makes a judgment, right? And this judgment is most likely going to be on the basis of outward appearance, right? So for example, he might look at a kid and maybe he looks kind of out of shape, right? He looks out of shape or not as physically fit as the other kids, right? So that child is going to make the judgment or make the determination that that child is out of shape based on his physical characteristics, right? And on the basis of that judgment that that child is out of shape, he's going to draw conclusions, right? So he's going to draw the specific conclusion that because that child is out of shape, that in the past, children that were similarly not so physically fit haven't done well in the game of dodgeball, right? So we have a judgment deeming someone as not physically fit or out of shape, and we have reasoning that individuals who are out of shape don't do well in dodgeball, right? So that's an example of reaching a particular conclusion based on evidence or based on prior evidence. Lastly, we have decision making, and that's the easiest to understand. Decision making is just choosing between multiple alternatives. So choosing, do I pick this kid or do I not pick this kid, right? So because he's judged to be out of shape, the team captain reasons based on prior experience or evidence that kids who are out of shape can't play dodgeball, and therefore he reaches the decision that he's going to pass and not pick that particular child. Okay, so a lot of our decisions are, like I said, based on reasoning or based on conclusions that we draw from prior experience. Right? So I'll give another example. Many of you are working right now to register for classes, right? And as you are deciding whether or not to register for a particular class, your judgments that underlie that decision are often going to be based on if you've had a class in that particular department before, or if you have had that particular professor before, right? So if you've taken 5 classes with that particular professor and you find them to be very animated, very friendly, in their material, very easy, or you've gotten an A in their classes before, based on that evidence, reasoning from that evidence, you might decide to take their class again. One more example, right? We are all ordering a lot of online food delivery nowadays. So if you have a favorite restaurant, maybe on DoorDash or Grubhub or wherever, and every time you order it, the food comes exactly when they say it's going to come, and it's always hot, and it has, you know, everything you need, your utensils and your straw and whatnot, and plenty of napkins, right? Then you would reason based on those prior experiences that if you were to decide to order again, the same thing would happen and that you would have a positive dining experience, right? So all of these examples illustrate the relationship between judgment, decision-making, and reasoning. Okay, so I mentioned that a lot of times the decisions that we make are going to be reasoned on the basis of prior experience, right? So prior experience or past experience can be really helpful in helping us sort of guide or determine what our present course of action should be, right? And by using prior experience as a guide, we can actually cut down on the amount of cognitive processing that we have to do, right? So instead of having to collect all of this data ourselves, right, to be sure that the decision that we reach is correct, we can just rely on sort of our daily log or our prior log of experiences that we've had and allow that to guide our present behavior. Right? So a lot of what we're going to talk about today are what are called heuristics. So heuristics are basically just rules of thumb that are going to be based on prior experience and are going to guide our conclusions, okay? But because they're mental shortcuts, they can sometimes lead us astray. So they're not exactly foolproof, I'll say that. Right? So again, a heuristic is basically a mental shortcut that is meant to ease the burden that we place on our cognitive architecture, so to speak. Right? So just like we have absent-mindedness and transience and other sorts of sins of memory to cut down on the amount of irrelevant information that we're forced to process, right? Heuristics are going to allow us to reach fast conclusions, usually based on our prior experience, without having to do a lot of extra processing. Okay, so they're going to require fewer cognitive resources, and more often than not, they're going to lead us to the correct answer, or they're going to lead us to an appropriate decision. However, because heuristics operate by ignoring a lot of redundant or unnecessary information, right? Sometimes they can result in errors or biased conclusions, right? Because usually we're ignoring information that we don't need, but sometimes that information can actually be valuable. And if we neglect to notice or incorporate that information in our decisions, then we can be led to the wrong conclusion or a bad decision, so to speak. Okay, so we've already defined what judgment, reasoning, and decision-making are. So for the remainder of the lecture, we're just going to discuss various examples of mental shortcuts that can bias our decision-making or lead us to incorrect conclusions. Okay? So hopefully by this point, you guys have all done the worksheet that I linked on Canvas or the activity that I linked on Canvas. So this will not be collected for a grade, but if you go through and answer all of the questions there, it's going to make it a lot easier for you to understand the rest of the lecture. Okay, So if you haven't already, go ahead and pull up that activity on Canvas and make sure you work all the way through all of the problems and then come back and listen to the rest of the lecture, right? Because each of those problems are going to correspond to a particular phenomenon that we talk about today, okay? Okay, so the first question I ask you on the activity is I ask you which words are more prevalent or more common? Words that begin with R or words in which R is the third letter? Okay. Well, this is the same question that Tversky and Kahneman asked their research participants in 1973. And when they asked them, 70% of people said that there are more words in the English language that start with R than words for which R is the third letter. And one of the reasons why people were more likely to choose words that start with R is because it was easier to think of words that start with R, like rain, run, real, than it is to think of words with R in the third position. So words like word and car, right? So words that start with R come to mind a lot more easily than words where R is the third letter, right? But it turns out there are many, 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 many more words with R in the third letter than there are that starts with R. So in this case, it's an example of an incorrect conclusion, right? But this is one of the most common mental shortcuts or heuristics that people use that again leads them to the incorrect decision, right? So this is called the availability heuristic, the idea that events that are more easily remembered are judged as more probable or more likely than events less easily remembered, right? So again, it's the idea that anything that is more readily available or anything that comes to mind easier is going to be judged more likely than something that doesn't come to mind as easily. Okay? Okay. So this is the second question that I asked you guys to answer on your worksheet, right? So it says some possible causes of death are listed below in pairs. Within each pair, which cause of death do you consider to be more likely for people in the United States? That is, if you randomly picked someone in the United States, would that person be more likely to die next year from cause A or cause B? Okay, so I wanted you guys to choose between each pair, cause A or cause B. Okay, so as it happened, researchers actually posed this same question to participants in an experiment in 1978, right? So in this slide, I have a table showing their results, okay? So let's break down this table together. So this table shows the results of, like I said, experiments in which people were asked to judge the relative prevalence of various causes of death. Okay, so for each pair of causes, the more likely cause is going to be listed on the left column. Okay, so the more likely cause is listed on the left column. The number in parentheses is going to indicate the relative frequency of the most likely cause as compared to the least likely cause or the less likely cause, right? And the number on the right is going to indicate the percentage of participants that chose the less likely cause. Okay, so let's look at an example together. So on the first pair, you're 20 times more likely to die from homicide than you are to die of an appendicitis. Okay? And in this particular example, only 9% of people chose the less likely cause. So 91% of participants correctly said that you were more likely to die of homicide than you were to die of an appendicitis, right? But quickly, if we look at some of the other pairs in the table, it becomes apparent that people are fairly bad at this task. So they're fairly bad at judging correctly the relative proportion of deaths or the more likely cause. So for example, one of the most striking examples is you're 920 times more likely to die from asthma than from botulism, right? But 41% of people assumed that botulism was the more likely cause. And similarly, 58% of people assumed you're more likely to die from a tornado than you are to die of asthma, but in reality, you're 20 times more likely to die from asthma than you are from dying in a tornado, right? So what's happening here? Why are people so bad at this task? Well, you might notice that many of the deaths that participants are assuming are more likely are things like tornadoes, botulism, an auto train collision, right? So all of those things are things that would very likely be front page news, right? So anybody who dies in a tornado or of botulism or in any kind of motor vehicle accident, right? That's probably going to show up on the news, right? So what that means is that we can think quite easily of examples of people dying in tornadoes, right? Because we've been sort of inundated with that in the news media, right? And again, because of the availability heuristic, one of our mental shortcuts is that whatever comes to mind most easily, we're going to deem more likely, right? So it's easy to think of people who have died in tornadoes or died in a tornado or what have you. And certainly people who have died of homicide, right? Because that is featured prominently in the news. So people are led to believe that those causes happen or those deaths happen more often than they do in reality. Okay, so let's look at some other examples of the availability heuristic. So we looked at, for example, estimates of the likelihood of causes of death and also the relative prevalence of various words and so forth. But the availability heuristic also comes into play when we evaluate ourselves or we evaluate other people based on personality characteristics, for example. So in this particular study, participants were asked to answer the question, how often have you been assertive? Right? So in one condition, they were asked to generate 6 examples, and in another condition, they were asked to generate 12. And then after generating their specific examples of instances where they've been assertive, they were asked to rate their own degree of assertiveness on a 5-point scale. And what the researchers found is that people who only came up with 6 examples of being assertive actually rated themselves higher on the assertiveness scale than individuals who came up with 12 examples, right? which doesn't really make sense, right? It seems like having to come up with 12 examples of all these instances where you've been assertive would lead you to the conclusion that you're more assertive than somebody who only had to come up with 6 examples. But what's happening here is it's easier to think of 6 examples of pretty much anything than it is to come up with 12 examples. And so because people in the 12 example condition kind of struggled and really had to think hard about prior instances of assertiveness, right? That led them to believe I must not be very assertive, right? Because these instances of assertiveness aren't coming to mind very easily, right? So this is another example of how the ease with which information comes to mind determines our subsequent judgments of something. Okay, one more example. So in this particular study, participants, which were actually students in a course, were asked to come up with either 2 ways the course could be improved or 10 ways, okay, the course could be improved, okay? And then they were asked for an overall rating of the class. And again, people who had to come up with 10 ways the course could be improved actually gave higher ratings of the class than individuals who had come up with only 2 ways, right? Again, because they had a hard time, right? It was difficult to come up with 10 potential improvements for the course. And so that led them to the conclusion, I'm having a really hard time coming up with proposed improvements for this class. It must be a really good class, right? So again, the ease with which we're able to generate examples for something is going to determine our subsequent judgments about it. All right, so time to move on to the next question, right? So this question says, we randomly pick one male from the population of the United States. That male, Robert, wears glasses, speaks quietly, and reads a lot. Is it more likely that Robert is a librarian or a farmer? And 3 points extra credit for anybody that gets the reference in that particular image of a librarian. Okay, so what is this question illustrating about heuristics or biases in decision making? So this particular question is referencing something called the representativeness heuristic. And it's essentially a cognitive bias where the outcome is predicted based on how similar a particular example of something is to a typical example of that category, right? So a lot of us, for example, decide to eat healthier, right? Or when we're deciding to eat healthier, we might choose foods based on how similar they appear to be to other healthy foods, right? So for example, fast food restaurants kind of capitalize on this. So they make sure that if you order a salad from McDonald's or wherever, right, that it has the appearance of having lots of really leafy, kind of green, lush vegetables, right? And maybe there's a lot of buzzwords like organic and free range and things like that. So again, you're trying to make the food that you're selling appear to be very similar to the physical features that a lot of people associate with healthy food, right? Similarly, we might predict that a person wearing glasses will do better on a test than a person not wearing glasses, right? Because we associate people wearing glasses, they seem more similar to our prototypical example of an intelligent person. So how is this at work in the problem that I just showed you, the farmer and librarian problem? Well, by and large, right, it seems that the description of Robert as someone wearing glasses, speaking quietly, and reading a lot matched people's typical image of what a librarian is, or they matched their assumptions about what a typical librarian is like, right? And so overwhelmingly, most people decided that Robert was a librarian because the description that was given matched their typical description of a librarian, right? Thus, they were influenced by the representativeness heuristic into basing their judgment on how closely the characteristics used to describe Robert matched the characteristics of a typical librarian, right? However, in making that decision or making that judgment, they were ignoring or discounting another important source of information. And that particular source of information is the base rates of farmers or librarians currently in the population, right? So when I say base rate, a base rate is the relative proportion of different classes of individuals in the population, right? So in 1972, when this experiment was carried out, there were many, many more male farmers in the population than male librarians in the United States. So just looking at the relative proportion of each occupation, right, it is much, much more likely that Robert is a farmer, okay? Because remember, Robert was randomly chosen from the population. So taking into account that there are many, many more farmers in the U.S. who are male than librarians who are male, it would stand to reason that if we were to just pluck someone at random, right, that they're more likely to be a farmer. And by the way, those base rates are still true today. Even in 2020, there are more male farmers than male librarians, right? But people tend to discount this information, and they're instead swayed to overweight the importance of those descriptions or other characteristics that they're given, right? So basically, people aren't thinking about it in terms of probability. Instead, they're thinking about it in terms of how well their own description of a librarian fits with the description provided in the problem. Okay, so one reaction to the farmer-librarian problem might be that perhaps participants were not aware of the base rates or the relative proportion of librarians and farmers in the population. And so because they didn't have this information, they weren't able to use it to make the correct decision, right? Well, fortunately, researchers devised an experiment to examine what happens when people are given the correct base rate information. So, for example, some participants were given this description. So it says, in a group of 100 people, there are 70 lawyers and 30 engineers. What is the chance that if we pick one person from the group at random, that the person will be an engineer? Right? Well, when they were given this description, people had no difficulty at all correctly answering that 30% of people drawn from the population would be an engineer. So when they're given the base rate information, right, they seem to be doing pretty well. However, another group of participants was given the same base rate information, but they were also given this description. So this description says Jack is a 45-year-old man. He is married and has 4 children. He is generally conservative and careful and ambitious. He shows no interest in political and social issues and spends most of his free time on his many hobbies, which include carpentry, sailing, and mathematical puzzles, right? So when the second description is added to the first description, people's estimates of the probability of Jack being an engineer go up substantially, right? So what that means is that even when people are given the correct base rate information, they tend to disregard that base rate information whenever any descriptive information is made available. Okay, so people are really, really bad at prioritizing or taking into account the base rate in their estimates, and will almost always choose descriptors above that. Okay. All right, so the next problem on your worksheet was the Linda problem. So it says, Linda is 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstrations. Which of the following alternatives is more probable? Okay, so the correct answer to this problem is actually statement 1. So statement 1 has a greater probability of being true than statement 2. However, when Tversky and Kahneman asked participants this same question in 1983, 85% of their participants chose statement 2, right? And it's easy to see why they did this when we consider the representativeness heuristic, right? So many of the characteristics in statement 2 are typical of what most people think of when they think of feminists, right? So because that description included many of the characteristics of a prototypical bank teller, people were prompted to choose that option. However, that is a faulty conclusion, right? And again, we can see that it's a faulty conclusion by considering the base rate, right? So if we think about the probability of something occurring in the population, it makes sense to think about something called the conjunction rule. And the conjunction rule simply states that the probability of 2 events occurring together cannot exceed the probability of any of those events occurring by themselves, right? So said another way, the probability of A and B can't be higher than the probability of A or B alone, right? So let's look at a separate example. So for example, the probability that Anne has a red Corvette can't be higher than the probability that Anne has a Corvette, right? Because if we look at the pool of cars available, right, there are far more Corvettes than red Corvettes, right? So again, the probability of getting a Corvette is much higher than the probability of getting a Corvette that's red, right? And similarly, there are many, many more bank tellers in the population than feminist bank tellers, right? So when we look at the base rate or the relative probability that Linda is a bank teller, it's much more likely, or that Linda is a bank teller or a feminist bank teller, it's much more likely that she is a bank teller, right? because the relative probability of just being a bank teller is much, much higher than the probability of being a feminist bank teller. Right? Okay, so the next question I asked you guys to answer on your worksheet was, a certain town is served by 2 hospitals. In the larger hospital, about 45 babies are born each day, and in the smaller hospital, about 15 babies are born each day. As you know, about 50% of all babies are boys. However, the exact percentage varies from day to day. Sometimes it may be higher than 50%, sometimes lower. For a period of 1 year, each hospital recorded the days on which more than 60% of the babies born were boys. Which hospital do you think recorded more such days? The larger hospital, the smaller hospital, or were they about the same? Okay, so let's take a look at this problem in more detail. So when Kahneman and Tversky asked participants this question in 1974, 22% of participants picked the large hospital, 22% of participants picked the small hospital, and 56% of participants said they were about the same, right? So presumably, most individuals assumed that both the large hospital and the small hospital would have birth rates for boys that were akin to that of the overall birth rate, or similar to that of the overall birth rate in the population, right? But as it turns out, the answer is the small hospital, right? So it's more likely that a small hospital is going to have more days where more boys are born than girls, right? So when we think about why this is the case, first we need to understand a statistical rule called the law of large numbers. So the law of large numbers basically says that the more individuals that are randomly drawn from the population, the more representative the resulting group will be of the entire population, right? So as the number of individuals that you randomly draw from the population goes up, okay, the more representative that sample is going to be of the population, right? And the inverse is also true. So as the number of individuals that you randomly draw from the population decreases, or as your sample gets smaller, it's going to be less representative of the entire population, right? So thus, in the hospital problem, it's more likely that the percentage of boys born on any given day will be near 50% in the large hospital and further away from 50% in the small hospital. Okay, so let's think about why this might be the case, right? So imagine there is a very small hospital that records only 1 birth on each day. Okay, so only 1 baby gets born each day. Over a period of a year, or 365 days, okay, we have 365 births per day, with about 50% being boys and 50% being girls. However, on any given day, there will either be 100% boys being born or 100% girls, because there's only that 1 baby, right? So clearly, the percentages that are observed on a single day are not going to be representative of the population and are going to be significantly higher than 50%. Okay, so that's the hospital problem. The next question I asked you guys to complete on your worksheet was I wanted you to choose between 4 options, right? So the question says, imagine that the United States is preparing for an outbreak of an unusual disease that is expected to kill 600 people. Okay, perhaps this particular example hits a little bit close to home for all of us, but we'll charge ahead. 2 alternative programs to combat the disease have been proposed. Assume that the exact scientific estimates of the consequences of the programs are as follows. If program A is adopted, 200 people will be saved. If program B is adopted, there is a 1/3 probability that 600 people will be saved and a 2/3 probability that no one will be saved. Which of the 2 programs would you favor? Now consider the following additional proposals for combating the same disease. If program C is adopted, 400 people will die. If program D is adopted, there is a 1/3 probability that nobody will die and a 2/3 probability that 600 people will die. Okay? Which of these programs would you pick? Right? So first you're choosing between A and B, and then you're choosing between C and D, right? So which programs did you guys pick? So the first thing to notice here, if you haven't noticed already, is that if we look closely at these 4 programs, there's actually identical pairs, right? So for example, in program A and program C, 400 people die, right? So in both programs, 400 people die, yet 72% of people chose program A, while only 22% of people chose program C, right? Similarly, program B and program D result in the exact same number of deaths, and yet 78% of people chose program D, while only 28% of people chose program B. So what is going on here? If it results in the same outcome, why are people choosing the programs at such a different rate, right? Well, Tversky and Kahneman, when they conducted this experiment in 1981, they proposed the following theory to explain it. So it was basically the idea that the reason why the rates of endorsement are so different are because of the way that the choices are stated or framed. Okay? So when participants were asked to choose initially between program A and program B, right? The choice is framed in terms of gains, right? So people are made to think about the possible benefits of enacting this program, right? So if you choose this program, 200 people are going to be saved, right? So because the question or the choices given are framed in terms of benefits or in terms of gains, people want certainty, right? So when people are thinking about the possible benefits or gains that they'll incur by adopting a particular strategy, they want the outcome to be as certain as possible, okay? And another way of saying they want the outcome to be as certain as possible is they're adopting a risk aversion strategy, okay? So they don't want to risk any people. They want the most certain strategy, right? However, even though the number of deaths is exactly the same, right? When participants are asked to choose between program C and program D, those choices are framed in terms of losses, or they're framed in terms of the number of deaths, right? And we don't like loss, right? You want to avoid loss at pretty much all costs, right? So in that case, because we're extremely motivated to avoid potential losses, okay, we're willing to risk more, okay? So now we're not as concerned about certainty. We just want to do everything we possibly can to avoid possible losses, right? So in that case, we're willing to take the riskier option, right? Or when things are framed in terms of losses, we're willing to adopt a more risk-taking strategy, right? So we're willing to gamble on the fact that there's a 2/3 of a chance that 600 people will die, rather than choosing a certainty that 400 people will die, right? So we like the certain option when we're made to think about it in terms of the number of lives saved, right? But we're willing to avoid losses at all costs, right? And in that case, we don't want the certain option. We want to do everything we can to avoid the possibility of a loss. So we're going to take the risk-taking strategy in an effort to avoid the potential for loss. Okay? So framing effects just mean the way that the choices are stated, whether they're stated in terms of gains or losses, is going to determine what we choose, even if the number of deaths or the outcomes are identical. Okay? So when something is framed in terms of gains, we crave certainty and we'll choose a risk aversion strategy to be certain that we're going to gain something, right? Whereas when it's framed in terms of what we lose or what gets taken away, we're willing to gamble and take a much more risky option or risk-taking strategy to avoid those losses. Okay? So just to recap, we have defined judgment, decision-making, and reasoning, and we have talked about various heuristics and biases that often lead us astray and make us less efficient or less effective decision makers. So we've talked about the fact that we often deem things that come to mind easier to be more probable than things that don't come to mind as quickly. We tend to choose we tend to assume that individuals who have more of the characteristics that we typically ascribe to a particular category to be more representative of that category, while not taking into account things like base rate. We tend to forget that not all samples represent the population and that the size of the sample matters. And we also tend to adopt different strategies depending upon the particular way that a question is framed. Okay, so that's just a very quick summary for all of you. Certainly, if you have any questions, do not hesitate to contact me, and I will see you guys soon. All right.